we'll write the Lewis dot structures for the ions. So here ions means cation or anion. Ion means a cation or anion. So we will write, first we will write for the cation. For cation, we'll take NH4 plus as an example. And for anion, we can take anything NO2 minus or CO3 2 minus, etc. Anything we can take. So here we have taken ammonium ion. So before writing into the, here there are, I told you there are some rules to follow while writing the structure, Lewis dot structure. Okay. So here first you have to calculate, step 1 you have to calculate number of valence electrons. So here nitrogen belongs to which group? Fifth group, and hydrogen it is first group, 1 into 4. So 4 hydrogen atoms are there. So here altogether 9 valence electrons. Now here I am adding another point. Here if cation is there, positive charge is there, if positive charge is there, so here number of valence electrons minus 1. So here how many valence electrons are there? 5 plus 4, and here minus 1, because here it is a cation. You subtract 1 electron from the total number of valence electrons. So altogether the valence electrons, number of valence electrons are 8. Okay. Now in the second step you have to write the step 2, you have to write the skeletal structure for any molecule. So here central atom. What is the central atom? I told you already, hydrogen and fluorine cannot be a central atoms because of its small size. And here least in number, nitrogen is the central atom here. So just central atom, and around the central atom and whatever the atoms are there, 4 hydrogen atoms are there, and 1 bond each. Now calculate bond pair of electrons. Second step, bond pair of electrons. Bond pair of electrons is equal to 2 into number of bonds. Bond pair of electrons is equal to 2 into number of bonds. How many bonds are there around the nitrogen? 1, 2, 3, 4 bonds are there. So 2 into 4, so which is equal to 8 electrons. This is step 2 we have completed. And the third one, it is step 3. Here it is lone pair of electrons. So how to calculate lone pair of electrons? Valence electrons minus bond pair of electrons. Valence electrons minus bond pair of electrons. It is 8 minus 8, which is equal to 0. So no lone pair of electrons. So if you observe starting from the corner, so here 2 bond pairs are there. 1, 2. Duplet is satisfied. Okay, and here 1, 2, here also duplet satisfied. 1, 2, duplet satisfied. 1, 2, duplet satisfied. Around the nitrogen. Now look at the nitrogen. Around the nitrogen 8 electrons are there already. So here octet satisfied. So plus charge on the nitrogen. So if you observe anywhere, nitrogen is having 4 bonds. Definitely there will be a positive charge on the nitrogen. Okay, so here the positive charge you should keep on a central atom. Okay, this is the way of writing the Lewis dot structure for an ion. Ion, here we have taken ammonium ion. First you have to calculate the valence electrons. So nitrogen belongs to 5th group, 5 valence electrons, and hydrogen belongs to 1st group, and 4 hydrogens, 1 into 4. 4 minus 1 for the cation, because it is a cation you have to subtract 1 from total number of valence electrons. So altogether 8 valence electrons. That is the first step. And in the second step, here you have to write the skeletal structure, and you have to decide which is the central atom. Central atom cannot be hydrogen and fluorine. Those two are not central atoms. Those two cannot be a central atoms. So here nitrogen is the central atom, obviously, because only 2 are there. So nitrogen around the central atom. First you write the skeletal structure. I told you already. So this is the skeletal structure, and after calculating the bond pair of electrons, 2 into number of bonds, which gives you a number of bond pair of electrons involved are 8 electrons, and the calculation of lone pair of electrons, valence electrons minus bond pairs, which is equal to 0, means 0 lone pair, so no issue. So here one by one you check from the corner atom. So hydrogen duplet satisfied. For all the hydrogens duplet satisfied, and around the nitrogen 8 electrons are there, octet completed, and it is an ammonium ion plus charge should be placed on the central atom, and because here nitrogen is bearing 4 bonds, so always there will be a positive charge on the ammonium, positive charge on the nitrogen. Okay, this is the way of writing Lewis dot structure for the cation. Now we will write the Lewis dot structure for these two. Okay. For the here anion, I am taking a carbonate ion. This is the same steps you have to follow to write the Lewis dot structure for this one also. And the first one, calculate the valence electrons. First step. First you have to decide which one is the central atom. Here carbon is the central atom. Here the central atom, what are the rules for the central atom? Here the central atom should be of least electronegative, least in number. Okay, and it should be of more size. So hydrogen and fluorine cannot be a central atoms because of their small size. Okay, these are the rules you have to remember while writing or while predicting the Lewis dot structures. Okay, so here among this carbon and oxygen, this is your central atom. Very good. Then valence electrons, first step to write the Lewis dot structure, it is the valence electrons. Here carbon belongs to which group? Fourth group, and 4 valence electrons simply. So here it is valence 1s2, 2s2, 2p2. I told you already, these are the valence electrons, these are the inner core electrons, will not participate in bonding. So valence electrons, and simply the particular element belongs to which group. So here it is the it belongs to 4th group. So number of valence electrons is equal to 4 plus. Here oxygen belongs to 6th group. So 3 oxygen atoms are there. 3 into 6, which is equal to 18. Here now 2 minus is there. You have to add 2 electrons. For the cation, if positive charge is there, you have to subtract from the valence electrons, and if negative charge is there, you have to add to the number of valence electrons. Here that charge you have to add in the valence electrons. So here how many? 24 electrons. Okay. Now second step, here you have decided what is the central atom. So here carbon is the central atom. So first write down the skeletal structure. Carbon, around the carbon, the corner atoms, 3 oxygen, whatever atoms are there, here oxygens are there. Next step, calculation of bond pair of electrons. Bond pair of electrons is equal to 2 into number of bonds. How many bonds are there? 3 bonds are there. So 6 electrons. How many bond pair of electrons? 6 bond pair of electrons. Next, lone pair of electrons. Lone pair of electrons is equal to valence electrons minus bond pair of electrons, which is equal to 24 minus 6, 18 electrons. 24 minus 6, it is 18 electrons. So here the 3 steps we have completed. Now these 18 electrons you start sharing from the corner atom, I told you. So here what is the corner atom? Here this is the corner atom. So here 1, 2, 3, 4, 5, 6, 7, 8. So octet of this, here I am numbering this one, it is 1. Octet of this oxygen has satisfied. Next come to this corner. Next we left with 12 more electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So octet of this second oxygen also satisfied. Now come to this third one. So here we left with 6 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Octet of the third one also satisfied. Now come to the central atom carbon. Here around the carbon atom only 6 electrons are there. So here octet of this one, octet of the carbon is not satisfied. So here this oxygen will share a pair of electrons with this carbon atom. Now what will be the structure? Here carbon, double bond O and single bond O and single bond O. Now I will write the lone pairs left over. 1, 2, 3, 4 on this oxygen. It is 1. 1, 2, 3, 4, 5, 6 on the second oxygen. So these are the bond pairs. And here 1, 2, 3, 4, 5, 6. This is the Lewis dot structure for the carbonate ion. Now here the problem is where to keep this negative charge. So here 2 minus is there. For this you have to calculate the formal charge, which is very important. Now the formula to calculate the formal charge is, you can make a note, formal charge is equal to number of valence electrons minus lone pairs minus 1 by 2 bond pairs, minus 1 by 2 bond pair, valence electrons minus lone pairs minus 1 by 2 bond pair of electrons. This is the formula for the calculation of formal charge. Now here I have numbered these oxygens. Now one by one you calculate the formal charge on this oxygen. So first one, oxygen 1. So first you calculate the formal charge on this oxygen. So O1, number of valence electrons. How many valence electrons are there on oxygen? 6 as usually. And the lone pairs, 1, 2, 3, 4 lone pairs minus. How many bond pairs? 1, 2, 3, 4. 4 bond pair of electrons. 1 by 2, 4 by 2. So which is equal to 6 minus 6, which is equal to 0. So, which means that formal charge 0 on this oxygen indicates that there is no charge on this oxygen. Simply. Second one, you calculate the formal charge for the second oxygen, O2. So, number of valence electrons minus lone pairs. How many lone pairs are there? 6. 1, 2, 3, 4, 5, 6. Okay. 1 by 2. How many bond pairs? Only 2. So, minus 1, 6 minus 7. So, which indicates that this oxygen is bearing a negative charge, minus 1. Clear? Next, calculate for O3. It is, how many valence electrons are there? As usually, oxygen 6 valence electrons. How many lone pairs? 1, 2, 3, 4, 5, 6. 6 minus 1 by 2. How many bond pairs? 1, 2. As usually it is minus 1. So here this indicates that this oxygen is also bearing a negative charge. And here if you calculate for the carbon also, carbon, here number of valence electrons, here 4 minus number of lone pairs 0 minus bond pairs 8 by 2. 1 by 2 bond pairs 0. There is no charge on the carbon atom. So like this you can calculate the formal charge on any atom. And here this is the way of writing Lewis dot structure for the anion. So one by one we'll discuss briefly. First here you have to decide what is the central atom. Central atom should be least in number, less electronegative and more in size. So here carbon is the central atom. Hydrogen and fluorine cannot act as a central atom because of their small size. I told you already number of times. So here first the steps involved in this are, this is the first step, this is the second step and it is the third one. And if at all here we are writing for an anion, number of valence electrons plus 2. So bond pair of electrons in the second step. Write the skeletal structure, central atom, corner atoms, 1 bond for each atom. So here how many bond pair of electrons? 2 into number of bonds. Number of how many bonds are there in a skeletal structure. So here 6 electrons and the lone pair of electrons, valence electrons minus bond pair of electrons, so 18 electrons, lone pair of electrons. Now you start sharing these, next point you have to remember, you start sharing these lone pairs from the corner atom. So here corner atom, you just here if we observe, here I'll tell you one trick. If here oxygen with a single bond, there will be definitely a negative charge. Okay. Oxygen with a triple bond, there will be a positive charge. Definitely you can observe anywhere. Oxygen here, before calculating formal charge also, this is the excellent trick. You can make a note of this trick. Here oxygen with a single bond, negative charge. So where to keep this negative charge before calculating the formal charge also? Here oxygen with a single bond, negative charge, oxygen with a single bond, negative charge, oxygen with a double bond, no charge, like that. Okay. So here after calculating the formal charge, what is the formula for formal charge? Valence electrons minus lone pairs minus 1/2 bond pairs. Okay, clear? This is the way of writing Lewis dot structure for the carbonate anions, carbonate ion. Okay, next we will discuss another example. Now, next example is NO2 minus. The same steps you follow. The central atom should be least in number, less electronegative. Nitrogen is the central atom. So here calculate the number of valence electrons. Valence electrons, nitrogen belongs to which group? Nitrogen and oxygen. Nitrogen belongs to fifth group, 5 valence electrons, 5. Plus here oxygen belongs to sixth group, 2 oxygen atoms are there, 2 into 6, 12. Here minus, so plus 1. So altogether 18 electrons, valence electrons. So step 1 we have done. And the second step, write the skeletal structure. Central atom, oxygen, oxygen. Okay, after 1 bond each. So after writing the skeletal structure, bond pair of electrons, 2 into number of bonds. So 2 into number of bonds means here how many bonds are there? 2 into 2, which is equal to 4 electrons. So how to calculate the lone pair of electrons? So here lone pair of electrons is equal to valence electrons minus bond pair of electrons. Valence electrons minus bond pair of electrons, 18 minus, here 18 minus 4, which is equal to 14 electrons. Okay. Now here start sharing these 14 electrons from the corner atom. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. This is one octet of this oxygen has satisfied. Next you come to this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Octet of this one has satisfied. So this is the second oxygen. 6 plus 6 is 12. We left with 2 electrons. So here 2 electrons, but here octet of this nitrogen is not satisfied. So start sharing these 2 electrons with this nitrogen. What will be the structure? Nitrogen, double bond, oxygen, and it is a single bond, oxygen. Whatever the lone pairs exist, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just here minus charge. Where to keep the minus charge? I told you in the previous example, oxygen with a single bond, negative charge. You can check with the by calculating the formal charge also. It is minus 1. There will be no charge on these oxygens. Here you can check now one by one. We'll check the formal charge. 1, 2, 3. So for first one, quickly check the formal charge on this oxygen. What is the formula for formal charge? Formal charge is equal to, here simply I am writing formal charge Fc. So what is the formula? Here valence electrons minus lone pairs minus 1/2 bond pair of electrons. This is the formula for calculation of formal charge. Over here quickly, oxygen, first oxygen, how many valence electrons? 6. How many lone pairs? 4. Minus 1 by 2, how many bond pairs? 1, 2, 3, 4. 4 by 2, 2, 6 minus 6, which is equal to 0. I told you, no? Second one. Now you calculate the formal charge on this oxygen, definitely you will get minus 1. Sure. 2. Number of valence electrons, 6. Minus 6 minus 2 by 2. 1. Okay. Now you calculate the formal charge on this nitrogen. Nitrogen valence electrons 5 minus lone pairs 2 minus here bond pairs 1, 2, 3, 4, 5, 6. 6 by 2, which is equal to 0. Okay. Chemistry will be very easy if you study in a proper way. Okay. So here it is the way, it is for NO2 minus. So here these are the steps involved. First decide what is the central atom. Here nitrogen is the central atom. Calculation of number of valence electrons, plus 1 for this minus. If it is a cation, minus 1 from the, subtract 1 from the valence electrons. So write the skeletal structures, bond pair of electrons calculation, lone pairs and formal charge. Formal charge, last one. Formal charge you calculate in the last. Okay. Now after that, now these are the steps involved. This is the Lewis dot structure for this NO2 minus. Okay. Clear? Okay. Clear? So if you want me to explain any particular topic or particular chapter, students please write me in the comment section. So definitely I'll make a video on that particular topic or the unit. Okay. Bye.